2 million years ago, Africa wasn't just the cradle of humanity, it was its crossroads. The continent swarmed with predators, giant hyenas, saber-toothed cats, crocodiles longer than buses. And standing among them were several upright apes. They walked like us, it may have even thought like us, but none ended up being us. And today, we'll be talking about one of them. Its skull was thick as armor, its teeth built for crushing, its face eerily human, that weird spot, too much but not nearly enough to feel uneasy when looking at them. It was very close to Australopithecus, even when it came to its brain case. Roughly chimp-sized, it couldn't paint, it couldn't speak, it may never have wondered who it was. And yet, starting 2.6 million years ago to 1.2 million years ago, it thrived. Meet Paranthropus, a genus of hominins that lived beside us for over 1 million years and then disappeared. And for decades, scientists weren't sure what to make of them. They weren't our ancestors, but they weren't just apes either. They made tools, maybe, used fire, possibly, contracted herpes from chimpanzees, and probably passed it on to us. Their fossils tell a story that's strange, contradictory, and uncomfortably close. Because Paranthropus isn't just a mystery from the past, they're a reminder that evolution didn't build a ladder, it built a tree. And for a long time, we weren't the only successful strategy on it. This is the story of the branch that broke off, and how they also might have shared herpes with us. The story of Paranthropus begins, like many things in paleoanthropology, by accident. In 1938, a South African schoolboy walking near a limestone cave picked up a fossil. It ended up in the hands of Robert Broom, a Scottish doctor turned fossil hunter who didn't care much for orthodoxy. He'd already clashed with establishment scientists over his belief that early humans came from Africa, not Asia, which were two confronting theories at the time. The fossil was strange. Its jawbone loudly screamed upright walking, clearly hominin, but way thicker and heavier. More brutal and primitive than anything seen before, gorilla-like teeth, and the face of a person. He named it Paranthropus robustus, which translates to beside man. Quite poetic, isn't it? The claim was wild, to say the least, especially at the time. Scientists preferred tidy trees and clean transitions. The idea that human evolution might have side paths, that it wasn't just a straight climb toward us, was hard to accept. Not a direct ancestor, but a parallel line, a cousin, a species that lived next to ours, not behind us. And as of today, it seemed like Broom was right. In the decades since, over 300 Paranthropus fossils have been unearthed, enough to show that this was a genus, a whole branch that was robust and, given its durability, very well adapted to its environment. At least 3 species now carry the name Paranthropus aethiopicus, Paranthropus boisei, Paranthropus robustus, different in shape, size, and geography, but united by their massive jaws and place outside our direct line. If you rewind the clock far enough, you'll find a quiet ancestor walking the wooded edges of ancient lakes. Her name was Australopithecus anamensis. She lived between 4.3 and 3.9 million years ago in what is now Kenya and Ethiopia. She stood upright. Her knees and ankle joints were built for bipedalism, but her long arms and curved fingers still betrayed a recent memory of climbing trees. And her teeth, thick enamel and large molars, spoke of a diet in flux. Fruit, sure, but also hard seeds, roots, tough vegetation, whatever it could get its hands on. Anamensis was an omnivore in a changing world, and that, more than anything else, may have shaped the story that followed. Because around this time, East Africa was undergoing major climatic shifts. Forests were shrinking, grasslands were spreading, rainfall became less predictable, and the organisms living in those ecosystems, especially primates, had a choice: adapt or fade. What happened next wasn't a clean split. It was an evolutionary pressure applied over thousands of generations. Some populations of Australopiths leaned into generalism, mobile, versatile, ready to eat whatever they could find, because there wasn't much to find of each back then. That line eventually would lead to Homo genus, and others leaned into specialization. They doubled down on toughness. Their skulls thickened, their jaws grew broader, their molars ballooned in size. They evolved massive chewing muscles, anchored to ridges of bone running along the top of the skull like a mohawk. They weren't chasing meat or fire or complexity. They were chewing, a whole lot of chewing. Because there wasn't much to eat at all, they specialized to be able to eat more of the same resources inaccessible if you didn't possess their massive teeth and jaw muscles. This divergence is a textbook case of niche partitioning, a concept in ecology where closely related species reduce competition by specializing in different resources or behaviors. It explains how lions and hyenas coexist, how warblers feed in different parts of a tree, and in this case, how two upright apes could live side by side for nearly 1,000,000 years without outcompeting each other. One, a generalist lineage, evolved to eat plenty of everything. This led to less jaw muscles and bones, more energy towards the brain. Then came tools, fire use, which enabled for more energy being redirected towards the brain, all the while to culture and who we are today. On the other side, a specialist lineage evolved into Paranthropus, a hominin built not for flexibility, but for resilience. It didn't need to explore new lands or environments, as its adaptations enabled it to find enough food. The earliest fossils we now assign to Paranthropus appear by 2.6 million years ago, but based on the speed of morphological change, especially the thickening of enamel and the development of cranial crests, it's likely the lineage began forming well before that, probably somewhere around 3 million years ago. Two very different kinds of humans started walking in different directions, with only one of them still being represented today. But still, the other run in parallel for a long enough time to have an impact on us as well. Evolution doesn't play favorites. It rewards what works. And for Paranthropus, what worked was chewing. Not talking, not thinking, not building fires or throwing spears. Pure grinding, day after day, like your average RPG. Except it was through some of the toughest foods the African landscape could offer, and only to survive, not to level up. They weren't fast, they weren't particularly smart, but they were unbreakable. It all starts with the jaw, broad, deep, and thick. The zygomatic arches, aka the cheekbones, flare out so far they look almost alien, making room for massive temporalis muscles that run from the jaw to the top of the head, and that's where it gets even stranger. Because on the top of the skull, especially in Paranthropus boisei, is a ridge of bone called the sagittal crest, where those muscles were anchored. It added significant strength, structure, and raw power. Gorillas have them too, but in Paranthropus, they reached even more absurd proportions. These were biological hydraulic presses. The estimated bite force of Paranthropus boisei falls between 1,300 and 1,800 newtons at the molars. That's nearly double the estimated bite force of early Homo species like Homo habilis, and remarkably comparable to even exceeding that of modern gorillas, whose bite force typically ranges between 1,200 and 1,500 newtons. And this force was made for a very specific diet. Microwear and isotopic analysis of their teeth made back in 2008, again especially on Paranthropus boisei, reveals a heavy reliance on C4 plants, tough fibrous grasses, and underground storage organs. These are the kinds of foods modern humans typically avoid unless they're starving. But Paranthropus was feeding on them, enough to have developed a specialization towards these. When fruit was scarce, they could dig. When drought hit, They could chew what no one else could. Honey may also have been on the menu, evidenced by high rates of dental cavities and Paranthropus robustus, a sweet reward hidden in a world of thorns. And what about the brain? Well, small, but comparable to the capacity of Australopithecus in the same period, roughly 450 to 550 cubic centimeters, bigger than a chimp's, but smaller than early Homo. But that wasn't a failure. It was a strategy. Brains are metabolically expensive. Today, our own brains burn about 20% of our daily calories. But to survive, Paranthropus didn't need symbolic thought or language or complex planning. Their niche was stable. Their bodies were specialized. Big brains were unnecessary weight. They had carved out an ecological role, and evolution sculpted them to fit it perfectly. Today, we recognize at least 3 distinct species. Paranthropus ethiopicus, the earliest of the 3, emerging around 2.6 million years ago, best known from the black skull with its exaggerated crest and primitive features, likely the ancestor of Paranthropus boisei, the titan of the group, appearing around 2.5 million years ago and surviving for over 1 million years in East Africa. Nicknamed Nutcracker Man, though ironically, evidence shows it wasn't limited to hard foods, it just could eat them when it had to. And finally, Paranthropus robustus, slightly younger, appearing around 2.2 million years ago in South Africa. Smaller bodied, more generalized in diet, but still unmistakably part of the same genus. There's no telling why the genus would tend towards more generalized food, but it seems it happened. All were short, about 4 feet tall, stocky, dimorphic, with males outweighing females by nearly 50%. At a glance, Paranthropus was built for reliability. Its face is dramatic, broad cheekbones, sloping forehead, jaw like a hydraulic press. The rest of the body screams compact and efficient. Fossil estimates suggest that males stood around 137 centimeters tall and weighed roughly 49 kilograms. Females on average were closer to 124 centimeters and 34 kilograms. That's a level of sexual dimorphism comparable to modern gorillas, suggesting strong male competition or polygynous social structures close to ape-like societies. And yet, despite their gorilla-like proportions, they didn't move like apes. Paranthropus was fully bipedal. Its legs and pelvis were built for upright walking, no different in the essentials from early Homo. They walked the same landscapes, stood at the same watering holes, and probably crossed paths more than once. But their upper bodies tell a more primitive story. Shoulder and arm bones suggest ape-like traits lingered: powerful shoulders, curved fingers, maybe some climbing ability, but not dependence. Their hands weren't adapted for life in the trees. They were adapted for life on the ground, possibly for digging, possibly for tool use. And what's most remarkable isn't what changed, it's what didn't. From the earliest known fossils to the last over nearly 1 million years, Paranthropus boisei barely budged in morphology. No massive brain expansion, no reduction in tooth size, no dramatic shifts in limb proportions. Meaning that Paranthropus from emergence to extinction was fully functional and didn't require much more adaptations to survive. Because when an organism doesn't change much over time, it usually means one thing: it was already well adapted to its niche. Stable environments favor stability in form. The pressures that shaped Paranthropus, fibrous diets, low mobility, fallback foods, remained consistent. So did they, till it all disappeared. While Homo erectus was inventing hand axes and chasing game across continents, Paranthropus was staying put, grinding tubers, weathering dry seasons, surviving. Not by becoming something new, it just perfected the formula. Even though that formula was already quite good for survival and their brains weren't exactly as big as ours, doesn't mean Paranthropus lived in ignorance of tools nor of fire. For decades, tool use was assumed to belong to our genus alone. The word homo itself became shorthand for hands that shape and minds that imagine. But the line keeps on being blurred with every new study released. Paranthropus had hands capable of precision grip, that subtle, dexterous motion of finger and thumb that lets us hold a pen, peel a fruit, or shape a stone. That doesn't prove they made tools, but it proves they could have. At multiple cave sites across southern Africa, researchers have found long bones, horn cores, and mandibles with wear patterns that suggest deliberate use. These were not randomly broken scraps. Some were shaped, some were held, some were pointed and smoothed. Bone tools like these are often associated with digging, especially for tubers or termites. A million years ago, that kind of behavior could mean the difference between hunger and survival. And the correlation is strong. Sites with Paranthropus remains contain more bone tools than those with Homo erectus, which raises a question: who were the true tool makers? In 2023, a study at a Kenyan butchery site turned up a clue. Among the remains of a butchered hippopotamus, stone tools nearby, meat expertly removed, was a single Paranthropus molar. No smoking gun, but a strong hint. If they weren't making the tools, they were at least there when the butchery happened. Maybe they scavenged, imitated, or learned. That's not a far-fetched assumption. Today, wild orangutans have been photographed attempting to spear fish after watching local fishermen. The attempt failed, but this isn't what's important. That's the same kind of cognitive soil from which learning and culture grows. And even more surprising, there's fire. At Swartkrans Cave in South Africa, researchers examined over 60,000 bone fragments. Among them, 270 had been burnt, scattered across multiple layers dating from 1.5 to 1 million years ago. Some bore cut marks. Many showed signs of having been heated to 300 degrees Celsius, consistent with controlled fire. And in the very same layers were fossils of Paranthropus robustus. It's not conclusive. Homo erectus was present too, and their use of fire is more clearly established. But archaeologists aren't ready to rule Paranthropus out, because brain size isn't the only metric that matters. Intentional fire may not require symbolic thinking. It may just require patience, observation, and the ability to carry a glowing branch from one place to another. And Paranthropus may have had all three. We'll probably never find a skeleton holding a burnt stick, but between the bone tools, the butchery sites, and the scorched layers of ash, one thing is becoming clear. Paranthropus didn't just survive the ancient world, they may have shaped it. To better understand Paranthropus, you have to imagine their world, not as a museum diorama, but as a living, breathing gauntlet of survival. They lived in eastern and southern Africa during the Pleistocene, between roughly 2.6 and 1 million years ago, from Pliocene to lower Pleistocene. Their habitats ranged from open savannas to dense woodlands, from arid shrublands to humid wetlands. Their adaptability was in habitat tolerance, in the ability to find edible roots in dry seasons and shelter near the water's edge. And water, for all its life-giving value, was dangerous. Streams, lakes, and floodplains were home to one of the most terrifying neighbors, Crocodylus anthropophagus, an extinct crocodile species. It likely reached lengths of 7.5 meters, 25 feet. Its name literally means man-eating crocodile, and fossilized hominin bones from Olduvai Gorge bear its bite marks, puncture wounds in feet, limbs, even torsos. They were part of life. But crocodiles weren't the only threat. Paranthropus shared the Pleistocene with saber-toothed cats like Dinofelis and Meganterion, predators built for ambush and equipped with elongated canines capable of slicing through hide and muscle. Their ancestors likely hunted hominins. Even more unsettling were the primates. Dinopithecus, a giant relative of the modern baboon, was as tall as a man and weighed over 170 pounds, 77 kilograms. With fangs up to 12 centimeters long, they weren't just aggressive, they were terrifying. Modern baboons are already known to kill rivals. Scale that up, and you get an apex omnivore capable of holding territory and defending it violently, even against their own predators. Then there was Theropithecus oswaldi, an extinct gelada-like monkey weighing up to 160 pounds, 72 kilograms. Highly territorial, potentially aggressive, and almost certainly unafraid of other primates. In other words, Paranthropus, with its build, stood absolutely no chance against any of them. They lived in an ecosystem that targeted them, and all the while, they were never alone. From their emergence to their extinction, Paranthropus coexisted with other hominins, Homo habilis, Homo rudolphinus, Homo erectus, for millennia. The fossil record hints at their proximity. The ecological logic confirms it. This wasn't a story of isolation, it was one of overlap, species sharing space, resources, and danger. And in that crucible, evolution shaped very different strategies. Some picked up tools, others picked up roots, but none of them, Paranthropus included, had it easy. In 2024, a team of researchers published something remarkable: footprints. Preserved in ancient sediment in what is now Kenya, the prints were dated to around 1.5 million years ago, a moment when multiple hominin species still roamed Africa. But these weren't all from the same kind of human. The trackways revealed two distinct walking styles, two anatomies, two gaits. One set was taller, more human-like, likely Homo erectus. The other, shorter, stockier, with a different distribution of pressure across the foot, almost certainly Paranthropus. And here's the part that matters. The tracks were laid down hours or days apart, meaning they followed each other. For over 1 million years, Paranthropus and early Homo species walked the same paths. They foraged under the same trees. They heard the same predators in the grass. They saw each other. And the question that follows is both obvious and impossible. What did they do about it? Some scientists argue for competition. Two upright apes, both bipedal, both omnivorous, vying for limited resources in a drought-prone world. Others point to niche partitioning. Paranthropus with its fallback plants and digging sticks, Homo with its carcasses and cutting tools as a recipe for coexistence. But there's another possibility: cultural learning. Today, chimpanzees watch each other use tools and mimic what they see. Orangutans imitate human behaviors after brief exposure, and Paranthropus, with a brain slightly larger than a chimp's and hands capable of precision grips, may have been watching Homo erectus butcher carcasses and carry embers from a dying fire. They may not have understood what they saw, but they may have understood enough to copy it. And in a world where survival could depend on just one new behavior, that kind of mimicry, intentional or not, might have mattered. We like to imagine a clear line between our genus and all the others, between humans and not quite humans. But the footprints in Kenya tell a different story. For one brief window, at least two kinds of upright apes passed through the same place, close enough to see one another, close enough to learn. For a long time, the genetic history of Paranthropus was assumed lost. Unlike Neanderthals or Denisovans, whose bones have yielded whole genomes, Paranthropus seemed too old, too fossilized, too far gone for its DNA to survive the ravages of time. But in 2023, that changed. From the enamel of a single tooth dated to around 2 million years ago, researchers recovered fragmentary genetic material. It was degraded, partial, fragile, but it was there, making it the oldest hominin DNA ever sequenced. That tiny sliver opened a window. We still don't have a full genome, not even close, but even a fragment is enough to start asking bigger questions about Paranthropus's place on the human family tree, about its divergence from other australopiths, about what ancient genes it might have carried forward or passed on. Because as it turns out, genetics doesn't just tell us where we came from, it also tells us what we shared. And around 1.6 million years ago, another mystery was brewing, this time not in bones, but in viruses. One strain of herpes simplex virus, known as HSV2, looks strikingly different from the one we've carried since our common ancestor with chimps, HSV1. In fact, HSV2 is more closely related to the version found in chimpanzees today, which means, at some point, it jumped species. And the genetic evidence points to Paranthropus boisei as the intermediary host. A 2017 study used phylogenetic modeling to argue that Paranthropus was the most plausible intermediary, living in the right place at the right time, overlapping with both chimps and early Homo. How exactly the virus moved is still debated. It could have been through predation, blood exposure, scavenging, or interspecies sexual contact. None of these possibilities are pleasant, but they're all biologically plausible. Modern examples exist. HIV jumped from chimpanzees to humans through contact with infected blood. Herpes, which typically spreads through mucous membranes or close physical interaction, wouldn't have needed much more. What matters is this: Paranthropus wasn't isolated from chimps. Neither was it from our ancestors. They may have formed a viral bridge between species. In doing so, they left behind a legacy somehow, in the molecular signature of a pathogen that infects over 500 million people today. But if their adaptations made them so resilient, how did they go extinct? By around 1 million years ago, Paranthropus was gone. And unlike Neanderthals or other hominins, they left no cultural traces, no tools with clear ownership, no burials, no stories, just bones. So what happened? The likeliest answer is the one that ends most evolutionary branches. The world changed. The Pleistocene was never a stable time. Around 1.2 million years ago, Earth entered what's known as the mid-Pleistocene transition, a major shift in glacial cycles that brought longer, more intense ice ages. In Africa, that meant growing aridity, shifting rainfall patterns, and the shrinking of wetlands and forest patches, exactly the kinds of habitats Paranthropus had relied on. Specialization, once a strength, became a trap. Where our ancestors had broader diets, could move, adapt, scavenge new foods, and cross ecological boundaries, Paranthropus was anchored. Built for chewing tough roots and grasses, they lacked the flexibility to pivot when those plants grew scarce. And while they had coexisted with early Homo for hundreds of thousands of years, Homo habilis, Homo rudolphinus, all the way to Homo erectus, there's no sign of direct conflict, no mass die-offs, no weapon marks, no evidence of extermination. Some populations may have faded as droughts dried up their foraging zones. Others may have dwindled as reproductive isolation and genetic drift took hold in fragmented habitats. Their final moments are lost to time. Paranthropus didn't fail because it was flawed. It succeeded spectacularly for longer than most Homo species. But success is never permanent. They were the specialists, but these are needed only so long as the environment they were specialized for. We don't put Paranthropus in our family albums. They weren't direct ancestors, just the very weird cousins meddling too close to chimps. They didn't leave us tools or tails. Their DNA, as far as we can tell, didn't shape us in any way. We just walked next to each other for over 1 million years. That's longer than Homo sapiens have existed, longer than the pyramids, the wheel, agriculture, and writing combined. By every evolutionary measure that matters, survival, reproduction, adaptation, Paranthropus was a success. Their bodies were built for their world. Their strategy worked. They didn't need symbols, fire, or anything more to conquer the planet. And they did. But Paranthropus challenges our frame of humanity. They were upright apes with precision grips, shared landscapes, and maybe shared knowledge. They may have used tools. They may have used fire. And they even gave us diseases we would have preferred they kept for themselves. A version of humans that didn't write myths or build cities. A parallel path that didn't lead to us. And if they had survived, if a group of robust bone tool using hominins still walked the forests of southern Africa today, how would we see them? Would we recognize them as people? Would we grant them rights, respect? Or would we fear them, study them, lock them away? We'll never know, but their bones still ask the question, would we have gotten herpes anyway? Paranthropus remind us that evolution isn't a march toward perfection. It's a tangle of paths, some leading forward, some looping back, and some that simply end. They were strong, they were stable, they survived the Pleistocene when so many others didn't. Why? We'll probably never know for sure, but they're a reminder that we are not the only story evolution ever tried to tell, and that our ancestors might not have been stopped by some half-ape, half-human booty cheeks when they saw one. Thanks for watching. If this story sparked something in you, curiosity, wonder, even a weird respect for a forgotten cousin, don't let it fade. Subscribe for more stories from the edge of extinction. Like the video to show the algorithm these echoes still matter. Share it with someone who got herpes. And as always, keep listening to the echoes.